Right, here we're looking at section 8.2, and our learning targets for the section are we're going to use the angle-angle similarity theorem, and then we're going to solve some real-life problems. So let's figure out what the angle-angle similarity theorem states. So what it really says is if two angles of one triangle are congruent to two angles of another triangle, then my two triangles are similar. Now remember, when we're talking about similar triangles, then I know that the angles are all congruent and the side lengths are all in proportion. So what this tells me that if I know two of the angles of both of my triangles, then I know that my side lengths will all be in proportion. So here what we're saying is if angle A is congruent to angle D and angle B is congruent to angle E, then I know that my triangles are similar. So I can use that information to help me find some information about the side lengths as well. So let's look at this example. So determine whether the triangles are similar. If they are, write a similarity statement and explain your reasoning. So one thing I notice is that these triangles are not drawn in the same kind of order, right? One's kind of, the right angle's upside down. So first thing I would do is I would redraw this little triangle so that it fits. And I know that this is going to be angle D, this is C, and this is E. Right, so all I've done is I've rotated this smaller triangle so it would kind of fit, and I'm going to label what I know. So I see that this would be 26 degrees. Well, so I don't know much about these triangles yet. I know that they both have a right angle, which is going to be one of our congruent angles, but the other two are not labeled the same. So let's look at this big triangle and see what this angle K would be, because I know angle C and K are corresponding, so let's see what we would get. So I know that an entire triangle has 180 degrees, and I know that I have a right angle here, so I know I only have 90 degrees left. So if I take 90 minus 64, what I already have, and then I solve for that, I end up with 26 degrees. So I know that this angle K is 26 degrees. Well, now I see that this angle and this angle have the same angle measurements, so I know that they are congruent. So I see that I've got two different angles that are congruent in my triangle, so I know that they're similar. So here was our triangle sum theorem, right? That's just what we did here. We found our extra angle so that we know that they are congruent. So here's our similarity statement, right? So I do know that triangle CDE is similar, that's what this little one squiggly means, to triangle KGH by the angle-angle similarity theorem. We just looked at the angles, we didn't have to deal with the sides at all. So now let's look at another couple of examples. So show that the true triangles are similar. So I'm told that they're similar, so now I have to actually just show that. So let's look at A. So I know the angles, I'm given angle B and I'm given angle C, and I know that they're equal, so I can say that. So, and then I know that angle A is the same thing in both triangles, right? Because it's the same angle and it looks here. So if I was to redraw these triangles, I could just pull the little triangle out and it would look something like this, right? This would be angle A, this would be E, and this would be B, and this would still be 52 degrees. And this angle A is the same as this angle A in the big triangle. So I know that those are similar because both of those angles are congruent. So now let's look at B. So some of the things that I know is I am dealing with parallel lines, so that can help me, right? Because I'm dealing with parallel lines and some transversals. I also see here I have two of my lines that intersect, and I know something about those angles because they're opposite, so they are vertical angles. So I know that SVR, let me draw this one in color. So SVR, so this one right here, and UVT right here are congruent because they're vertical angles, right? They're across from an intersection point. So I'm also told that these lines are parallel by these arrows, so that tells me some more about these angles. So I know that angle S is congruent to angle U, right? Because they are alternate interior angles. Oh, and they drew this down here a little bit so we could see what they're talking about. So now that I've found two angles in my triangle that are congruent, I know and I can prove that my triangles are similar. And it doesn't have to be these two specific angles. I could also say that R and T are congruent, and I know that also because they're also in alternate interior angles, right? Because if I know two angles in a triangle, I know the third because of my that all triangles add to 180. So now I want you to try this one. See what you can come up with and finding the different values and trying to determine if the triangles are similar or not. So now we're going to look at our second learning target, which is solving those real life problems. So a flagpole casts a shadow that is 50 feet long, right? So here's my shadow. At the same time, a woman standing nearby who is 5 feet 4 inches tall casts a shadow that is 40 inches long. How tall is the flagpole to the nearest foot? So the first thing I want to do is I always want to draw my picture and understand what I have and what I need. So here we go. This is where we're drawing our picture. Okay, so we're going to be using similar triangles. So now I just draw out my two triangles. Well, I know the flagpole is the thing that I'm looking for, so that's my X. The shadow that it makes is 50 feet. And I know that the woman is 5 feet 4 inches tall and that her shadow is 40 inches. Both of those things are standing at 90-degree angles to the ground. The sun is hitting at the same angle, right? So I know that these two angles are the same. So I can say that these are similar triangles and use that to help me. So now I use my proportion. So I don't want to deal with feet and inches. When I'm given feet and inches, I just want to deal with inches. So I'm going to rewrite this 5 feet 4 inches as 64 inches so that I can use my different ratios, right? So I've got my X feet, right? The height in feet is the same thing as 64 inches, it's the same side of those triangles, equals 50 feet, which is the length of the shadow, over 40 inches, right? I just wrote my proportion in my similar triangles. If I really wanted to convert all of these to inches first and then convert them back to feet, I could. Or I can just leave the large triangle in feet and the small triangle in inches. It works the same way. So now that I have my proportion, I just multiply both sides by 64, or I cross multiply, right? So I would end up with 40x equals 3,200, because 64 times 50. Then I can solve for x by dividing by 40. So now that I've found x, I want to just rewrite it as my final statement that I know that the flagpole is 80 feet tall. So then I just want to double check and see if that answer seems reasonable. So I see that the woman is quite a bit taller, but not twice as tall as her shadow. And so if I get that this is, right, 80 feet, it's taller, but not twice as tall as the shadow, so that does actually make sense mathematically. So now here's your last couple of monitoring progress. Try them and see how you do. This was actually a pretty short section using these theorems. Okay, so let's look back at our learning targets. Our first one is use the angle-angle similarity theorem. So this we're going to be using multiple times, either to show that they are triangles are similar, or if we're given similar triangles, to find the angles that are congruent. And then we use this to solve some real-life problems. So now that we've gone through these learning targets, go ahead and start working on your homework for 8.2.